So the title of this talk is Good Data Gone Bad, Bad Data Gone Worse. If this is not the talk you were expecting, please stay. You'll have a good time. This is a gigantic photograph of myself. My name is Renee. I am a data analyst. I specialize in data quality, and as I just said, I especially enjoy data that is broken or bad in some way, as most data sets contain something that is broken or bad that I find very fun. So I'm here to talk to you today from New York. That is where I live. This is a photograph of taxis at night in a blurry nighttime New York City. I imagine that's Times Square, but it could be really anywhere in the city. You can find me on Twitter at DataRenee. I like it when people follow me. I talk a little bit about data and a whole lot about like feminist stuff. So if you like seeing people talk about feminist stuff, I'm a good person to follow. I also love talking about data. So what this talk is about is how good data gets bad and then how bad data gets worse. So we're going to briefly talk about a couple of foundational things here. One of the things is we're going to talk about data. So we are going to insist that data is a thing. If you want to talk about whether data can be an imaginary thing or not a real thing, that's a PhD. Please go back to school and study that for 7 years. Data is pieces of information that have a specific format, and for our purposes, we can think of data as being facts that we're going to use to make choices or decisions, and we're going to think of data as that information being stored in a computer or used by a computer. I like to think of data very simply as a representation of some aspect of our world. So like I said, we're not going to argue over whether this is true or possible or not. Those arguments are being had all over the world. They are very fun. I love them. We're not doing that today. So good data is a very specific kind of data, and for the purposes of this talk, good data simply means that it is data that is useful for the thing we're hoping to achieve or do. I have some other opinions about other kinds of data that are bad, like stolen data or biased data. And sometimes that data is not useful for what we want to do, but this is a very narrow concept of good data. So what do we want to do with data? Usually what we want to do with data in some way is tied to a financial interest. And usually it's making or saving us money or preventing us or our company from losing money. But there are a couple of ways that we can outline this. So we want to make plans, we want to look smart, we want to improve our operations. Like I said, we want to save money, we want to make decisions, and a good database joke, we want to complete transactions. So bad data, as you might guess from the opposite of good data, bad data is simply data that's not fit for the use that we are intending it for. Does anybody have any questions or complaints so far? Wonderful. So we want to know, where are we going and can we get there? So this talk is going to assume that you and your organization have already decided where you're going. I am not going to help you decide where you're going, what you're wanting to do, how you want to save money. So there are some things that we want to think about in order to decide, is this data good? I didn't come up with these ideas myself. This one comes from the United Kingdom's branch of the International Data Management Association. I'll be posting these slides to the conference site, so you will be able to find them on the page for this. I didn't get them up yet. These 6 attributes are dimensions that this organization puts out as things that they think you should think about. And I agree. These are all incredibly important things to think about when you're assessing data. This list of things is 6 items. It is completeness, uniqueness, timeliness, validity, accuracy, and consistency. But I thought, there's more pieces to this puzzle of data quality, so I did a little more digging around, and I found that the Amsterdam Center for Health and Healthcare Research had a list of 5 items that they use for guidelines for data quality. And they want you to think about acquisition, entry, cleaning, storage, and analysis. And what you might notice about these 2 lists is this is like adjectives, and this is verbs. And I really like that. So I thought, this is really easy. We're just going to think about 3 things. Got 3 paths to go down, and that was my second terrible computing joke. It's 11 things. This is actually a lot of things to think about, and I only have about 40 minutes left. So don't worry. I jammed these 2 lists together and made a matrix. So I said, actually, these adjectives can each get impacted by these verbs. So I jammed acquisition and entry together. Then I took cleaning, storage, and analysis and took them by themselves. And then on the rows, I have accuracy, completeness, conformance, consistency, timeliness, uniqueness, and validity. Conformance and validity often get lumped together. So you'll hear me talk about them, and some of these things will sound a little familiar and similar. That's okay. The red X's that I've put in this matrix are the things I'm going to try to speed through in our remaining time. So I'm hoping to touch on how acquisition and entry touches on accuracy, completeness, conformance. I'm ignoring consistency here. Then timeliness, uniqueness, and validity. We'll briefly touch on how cleaning and completeness can be impacting each other. And then we'll look at storage, conformance, consistency, timeliness, and uniqueness. So as we go, I will show you in red how these things are connected that I will be talking about. So we're going to first talk about acquisition and accuracy. So accuracy is largely, does our database contain the value that is true? And like the discussion of does data exist, is truth a thing is another PhD program. So if you finish the is data a real thing PhD, you can move on to is truth a thing. So about a year ago, I was flying to Europe, and I decided that I would finally join an airline reward. So I, in this case, was the data entry professional, giving the website information about myself so that the website could keep track of me as a person. So it said, hey, nice to meet you. Tell us about yourself. When's your birthday? I told this website my birthday. I'm not telling you my birthday. I don't like the happy birthday song. Don't ever sing it to me. I did tell it my gender. Then they returned the information to me basically to say, hey, do a little quality check. This is what you told us. And I said, that's not what I told you. Again, you're going to have to believe me because I'm still not telling you my birthday, and I'm not going to tell you how they messed it up. And I was a little upset because I thought, oh no, did I fat finger a drop-down box? So I went back again, and I said, I'm going to create a fake person who's also named Renee, and I'm going to look at the drop-down box to see if I messed it up or they messed it up. And what do you know about December? Does it ever come before January in a calendar? No. This is one of the 2 hardest problems in computer science. For those of you who don't know that joke, there are 2 versions of it. The first one is naming things, cache invalidation, and off by 1 errors. The other version of that is there are 2 hard problems in computer science. We only have 1 joke, and it's not funny. So just to be sure, I found a day that has a month that has 31 days, because I thought if this is an off by 1 error, it might be doing the wrong month with the wrong days, and it sure as shooting came back and told me that's not, August 31st isn't really a day. And I said, but it is. So it's not my fault, but it could have been. It could have been my fault. So sometimes your entry errors come from bad UX, bad UI. That was the case here. But sometimes it is actually the data entry professional, whether that's a user that you're counting on to actually know about themselves, or it's someone that you've hired to take Excel spreadsheets, read them and type them into the data. I really have seen this. Or it's someone taking a phone call and typing in a phone number and transposing numbers. So some things that we can do. When we design a database, always test the inputs so that you can verify that January whatever really comes back as January, and then test February, and then double check for leap years. There's a ton of testing that you can do. Test-driven development, a really great thing. Write your tests before you write your code is what David Steele would say. He's another Postgres person. Always talk to your front-end team about what their plans are for your database, because they may have a different plan than they're able to really articulate for you. So keep up with their process as they're going along. Keep your cats away from your computer. If you can't keep your cats away from your data entry process, install a program on your computer called PawSense. This also works for toddlers. If you have cat-like or toddler-like typing, PawSense pops up and says, I've detected cat-like typing. Are you a human being? Please verify that you're real. If you fail to verify that you're real, this prevents your blue screen of death or other data problems. You can also use Scott Hanselman's toddler smash, I think he called it, and he wrote that when he had a toddler a decade or so ago. So again, you may have errors in the entry, but you could also have unauthorized entry. I don't know if any of you have a cat on the payroll, but I sure don't. They're never earning their keep in my experience. But you may also have perhaps a malicious intent, somebody who has hacked into your system or used to work for you or is leaving soon and has some ideas about what they might do to make your life a little more difficult. So protect yourself from all kinds of different acquisition problems as far as entry goes. So some things that we can do, like I said, sometimes we're depending on other people to give us the information that we want, and so knowledge elicitation is really important. Knowledge elicitation is simply getting information out of a human being. And sometimes that's how you're designing your database. If you're designing a database for a profession that you've never had any contact with, you may not create what they actually need. You may name your columns accidentally, inaccurately, or incorrectly and give them the idea that they should be putting information into this column that should not be going into this column. So you may end up with, say, mixed values in a column or some other inappropriateness. Always set your database constraints appropriately. If you need a column to never be null, make sure you set it that way. However, if you need to let a column be null, make sure you set it that way. But additionally, set constraints on making sure that your data types are chosen appropriately. For instance, if you're using timestamps with time zones in some places and timestamps without time zones in other places, you are probably going to have a bad time. And it's not actually the entrant's fault, but it may look like the data entry professional's fault. And then, of course, as you're populating your database, you have some ideas of your anticipated values. Go ahead and check what you actually got. Because sometimes a whole lot of your values are going to come back different than you anticipated, and that may be because you weren't anticipating well, but it may also be because, for instance, maybe you've created a non-null column and your data entry professionals simply don't have the time to find that information. Maybe the information doesn't exist, so they're just making things up. For instance, how many floors does this building have? Well, perhaps there isn't actually a building in this space yet, so there are no floors. That would be null or 0, but you can't really know what someone's going to tell you. Or they may choose a number like 99 or 999 or 9,999. And 99, it's tempting to think that that is an obvious way of saying, I don't know. Wake up. But in a place like New York, we do have at least one building with 99 floors, or some large number of floors where 99 becomes plausible. And then, of course, maintain security. Assign your users and roles appropriately. Please do not ever make everyone a super user, because then you have people dropping your tables, and then you have super huge accuracy problems because no data is absolutely inaccurate, right? Now we're going to move on to another topic. We're just breezing right through all of this. I could make accuracy and entry just a 3-hour tutorial. Don't have time for that because this is all so interesting. Completeness and acquisition. Some of the things that I've already mentioned have given you some hints about how your data might become incomplete at at entry time. So sometimes there might be gaps between the data that we've received and the data that we expected. For instance, if we are doing the census and we knock on 100 doors, but only 20 people answer the door, we have 20% of our information. Is that as much information as we expected? Maybe, maybe not. Maybe somebody actually only knocked on 25 doors, but told us that they knocked on 100. So there are different ways to assess what you expected to get for the amount of data. We almost never expect to get a 100% response rate on any kind of survey tool. We do, of course, hope for that. Now, on the other hand, sometimes too much completeness becomes extremely suspicious. If your survey worker comes back and says, I got responses on all 100 doors in 2 hours, or even in 1 day, some people simply will not be home, will not trust to open the door. Maybe there was a minor at home and no adult. So this completeness goes 2 ways. If it's too complete, please be suspicious. Have an idea of what the expected survey response is for your instrument, and when you are assessing any data set, look at both sides of it. A very complete data set is very tempting to love, but it's sometimes a very bad sign. So completeness is really interesting because there are some places where it's possible to have all of the knowledge of a situation. Chess is a great example of this. Chess is a solved game. Chess computers is my understanding. I may be wrong about this, but my understanding is that a chess computer can just about always beat a human. I've got a shrug. I like it. We'll talk about this later. I have so many questions. But as a person, you can't really actually remember all of the possible chess moves. It's like theoretically possible to know everything. Cards, you absolutely cannot know everything. You have no real idea what the other person's cards are. You can make a pretty educated guess. In fact, there are people who make a lot of money making really good guesses, but there are also people who lose a lot of money making equally good guesses. Even if you've done everything right in a game of poker, you may still lose your shirt. And data can be like that. Sometimes the most complete data set that you can get may still lead you in a direction that can get you not quite the best result that you might hope for, but it still might be the best result that you can get given what you had. So how do we end up with completeness problems? Sometimes we do a bad job selecting our sample. Sometimes we just don't really understand the business problem, so we don't know where we're supposed to go to get enough information. And sometimes the data just doesn't exist. So some things that we can do are, again, talking to our domain experts, finding out who should we actually talk to, who are we missing? And this is something that we're hearing and seeing a lot more about. When we think about medical studies of people who have undergone procedures or who have had particular medical problems, most of us in this room are aware now that studies of medicine, but also psychology, are conducted on a population that is now known as WEIRD. And WEIRD is an acronym for Western, Educated, Industrialized, I forget what the R is, and the D is democratized, generally. And the W is sometimes, instead of westernized, referred to as white. And this can be a huge problem when you're trying to make money, because if you're not understanding how everybody is using your product or suffering from a health problem or recovering from a procedure, you may be missing a whole lot of data about how you could make that product better, how you could save lives, and of course, greedily, how you could make more money. So sometimes we need to find or create additional data sets. We may want to recruit people into our medical studies who haven't traditionally been considered. When we're creating focus groups, we may want to go into different neighborhoods or communities and ask outside of our networks. We've probably all heard about how to hire. it's very, very common to look within our networks to hire people. So our cousin's best friend is looking for a job doing something like what we do, or our college roommate is looking for a job doing something like what we do. But those affiliations tend to be people who are like us. So it's very helpful to go ask people who are a little bit less like yourself, not just for jobs, but about data collection. So now we're going to move on to completeness and cleaning. And I love cleaning data. Cleaning data is one way of dealing with a lot of problems. So here we have Mr. Trim. He's a hairdresser, and he's conveniently drawn in a cartoon. And what happens in this completeness idea is that sometimes we have to get rid of data. And this can be really painful if you're new to dealing with data, because bigger seems to always be better. I know that seems to be the case with diamonds, but it's not necessarily the case with data. So if it's not relevant, and sometimes we simply don't have the processing or storage capacity to deal with all of our data. So we may sample the data that we have. So we've already sampled the population, and now maybe we need to sample our data to make that even smaller. So relevance and size, problems for completeness. Filtering, just like coffee, we don't necessarily want coffee grounds in our drink. We also don't want inappropriate data in our drink of data to analyze. So, like I said, sometimes our data set is too large. It may contain unnecessary columns. It may contain unnecessary rows. So sometimes we can either hard delete or soft delete or otherwise disengage with some of the data that we've collected. So things that we can do to help ourselves with this problem, of course, we can get rid of data, but we can also be very selective about what we import. If we're familiar with our data set before we bring it in, we may not have to go through the problem of deleting it. We can also screen our data carefully by thinking about, do we need all of these rows? Do we need all of these columns? And finally, trim and filter as appropriate, because sometimes someone else is loading the data for you and you don't necessarily have the choice of, is it all there? Completeness and storage is a very fun problem. Storage is a security problem. So someone who has access, this is again an access and setting your roles appropriately. Someone who has access to your database can cause you a completeness problem. They can delete or little Bobby tables. That's an XKCD cartoon where a parent added some malicious code to the name of her child and just got rid of all of the students. So if you're not storing your data in a secure way, you can lose a lot of your data due to malicious or accidental events, but you can also lose data due to inappropriate storage size. It's very tempting now to think the cloud is an unlimited place where we can put our data, but as you may know, you have to pay for that space. So if you're only paying for a gigabyte of data and you try to put a terabyte into it, you may get some alerts. If the person who's receiving those alerts ignores them, some of your data may get lost. A lot of your data may get lost. If you simply don't pay your cloud storage bill, does all of your data just go away? Check with your provider. Additionally, your on-site storage, that is physical storage, may not be appropriately sized. And those losses can also be catastrophic. And I would bet a donut that someone in this room has seen or caused such a failure of storage. So be mindful of how and where you're storing your data. Obviously, sometimes we've chosen an incorrect storage size, maybe an incorrect storage method. If you're using a cloud provider and you select, I trust you, I'm just going to have this stored in one region with no failover and no additional regions for storage, what happens to you when that provider's entire East Coast goes down? I didn't hear anybody say you've lost all your data, but that's the answer. Maybe you've accidentally dropped a column, table, or database. Maybe someone who had a credential did that. It's painful. So be realistic about your data space needs and assess them frequently. Set a calendar alert once a month to think about how is our data growing. Because if you bought a terabyte of data in anticipating we're going to have a lot of super fast growth, and then 6 months later you discover that you still only have 10 gigabytes of data, maybe you don't want to be paying for all of that storage, but maybe you're still anticipating that very fast growth. Have your backups. That's plural. And trust your users. So apply your alerts and process to prevent loss. Have a system. As we know from the postmortem process, most failures are not the result of a person. We try to be blameless and think about how this is a result of a process. So try to make it as hard as possible to have a catastrophe. Cleaning and completeness. If you have incomplete data, it can be very tempting to use a placeholder. A banking institution 15 or 20 years ago wanted to send a letter to their incredibly rich customers to offer them a super great deal. And a programmer put the placeholder "rich bastard" for people whose name they did not know. Left that company, left that replacement, and didn't comment their code. So the new programmers on the project sent out this letter. And then they sent out this sales team with some very generous and conciliatory gifts. Now this, of course, was a bit of publicity, and some people say that bad publicity is good publicity. There's no such thing as bad publicity. One company who received this letter framed it and hung it on their wall because they were very amused. And then some other people called this banking institution and said, "We have a lot of money with you. Where's our rich bastard letter?" So it turns out to be a really funny anecdote, but if you're making a placeholder for something that's incomplete, empty, blank, not null, maybe consider "Dear esteemed customer," instead perhaps of swearing at people you'd like to get money from. I love this example. But you can also use pset null, which is one of the very few bits of actual code that I have in this. Just remember, if you want to make shruggy guy or any other sort of backslash in Postgres, that's an escape character, so you need to use 2. Remember that, for shruggy guy's sake. So because null is a black hole of data errors, and poor Mr. Rich Bastard came out of a null value. It's simply unknown. We don't know this person's name. A lot of people really like null. Null does things. The person who created null, Tony, what's Tony's last name? He's a knight. He's been knighted. Anyway, he has regrets. He has apologized for null. Pardon? Tony Hoare, H-O-A-R, yes. He says, he acknowledges that he thinks he's caused billions of dollars in losses by putting null into computer programming. Amuses me greatly. So the things that we need to do when dealing with our completeness and the ways that we clean for incomplete data. And cleaning for incomplete data is not just null, it's also spacebar, it's the horror of non-breaking spaces sneaking into your code. If you've ever seen that, it's hard to find. It's terrible. The difference between a dash and an M dash can cause you problems that look like incompleteness. Be very careful about this. This is a version of the talk that I gave in Milan. So Letitia's talk is not happening here, but it did happen in Milan, and it is available online. It's called Null, Meet Null, the Great Unknown, and it's fantastic. And again, like we said with Mr. Shruggy, you can make your nulls look like something different so you can distinguish them from spaces, because sometimes a space is meaningful data. We're down to conformance and back to acquisition. And what we want to know for conformance is it in a format that we expect and that is acceptable? So this is important for things like money and time and names. And names are especially interesting. But one of the ways that we get problems with conformance on entry and expectations are if someone is in charge of entering into your database images like this into a usable format, Postgres is really great because it gives you JSON-B. and it gives you images, and it gives you a lot of other things that some other databases can't do as far as data types. But a lot of people may not know about these really cool data types, and so they may try to transcribe this into text. So are they going to describe the drawing of the person on the right? Are they going to correctly use the quotation marks? How are you going to represent that the text wraps around that image? Are they going to understand the handwriting of the person on the right, or the left for that matter? How are they going to represent the bullet points? How are they going to handle the line breaks? Very, very interesting questions. There is no one right answer. When you're faced with data like this, make sure everybody on your team, and especially your data entry team, has an agreement of how to handle this. And with any data entry, the only thing I beg of you, and I beg this desperately, is if you just only hire one data entry person, you have failed that person and your entire project. Data entry is one extremely difficult, very taxing on the brain and also the hands. It's hard. It does not look hard, but it is physically hard and is very hard for the brain. So after about an hour or two of data entry, you run into problems. So give your data entry people breaks and other tasks for their brain's sake, but also have their data entry sets overlap so that you can compare entries. It's one of the best ways to find errors in entries is to say 2 people entered these same bits of information and 5 of them are different. So you have an audit process and a way to figure out when were these entered in that person's shifts. Do they need longer breaks? Do they need shorter times? Do they need more activities? Do they need to be fired? But if you just have one person doing all that, you can enter a lot of errors in the introduction. You can introduce errors in the entry process and not catch them for a very long time. So that's my plug for data entry QA. Please do it. Of course, this happens through errors in entry. Sometimes people just make mistakes. Sometimes we have limitations in our data collection. In a perfect world, we would not collect data through handwriting. This is not a perfect world. We collect data with a ton of handwriting. We collect drawings. We collect all kinds of artifacts of life. Because data in so many situations is just information about the world, and we've added stored in or used by a computer, you can see how maybe a sculpture or a drawing or a handwritten note can break some expectations. Be wary when you're transforming one piece of information from one data type to another. So things that we can do are testing the inputs as we design the databases. Who's heard me say that already? You all have. You may not remember it, but I've said it. This is something you really want to do at every step of database design. You also want to have, like I said before, I beg you, have multiple people doing the entry process so that you can compare the output. Maybe none of what's going in is going to come back out as what you expected, but maybe they're going to be consistently not what you expected, or maybe they'll be differently not what you expected. And then again, find additional data sets. Maybe something's available that's not a drawing, or text that also includes a drawing, just as one example. We also come upon problems with conformance and acquisition and entry when we deal with money. Some people really love the money type that Postgres has. Other people really do not like the money type that Postgres has. I'm not getting in the middle of this fight. I'm just going to tell you, if you need to handle money, think really hard about how you're going to do it, talk to a lot of people, and test it out. Because nearly every choice has some pitfalls and potentials. The biggest advice that I hear from people the most often is to select the integer type with the amount of precision that you need for your process. So if you're a gas station, maybe go to 3 digits of precision past the decimal point because you need that extra 9. But maybe you're dealing with a money type that literally never has a decimal point. Maybe you're dealing with a money type that has lots more decimal points. Choose wisely. Time is another place where conformance is a problem, because the year 0 does or does not exist depending on which database management system you're using. Postgres does not acknowledge year 0, rightly, because I don't think it exists. But again, other database management systems will give you a year 0. And then think about whether you mean before Common Era or BC, before Christ. Think about how you're going to handle negative time or any other negative numbers. So think about the challenges of time and money, and again, any other conformance issues you have as far as data types go and potential entries that you may get. For instance, if you have a time entry and someone gives you text, that's going to be a problem. But if you have a time column that's not conformance limited to timestamp and is a text field, that's going to give you all kinds of problems. So be aware also of calendar changes. Postgres does keep really good track of time across time. So different calendars Postgres is aware of, which is very cool. That's another 45-minute talk. Again, don't use the money type unless you really, really are familiar with your use case and you know that you need to use it. Also, leap seconds are a super huge problem. So look into that if you want really fun time problems. Think about daylight savings time and whether there are states that do or don't use daylight savings time, and be aware of the potential for offsets with time as well. So that's if you've set a time zone for England, but really it should have been California, you're going to have all kinds of problems. Machine-generated data is a really great way to possibly have entry errors, conformance, accuracy, validity, all kinds of problems come with machines. Sometimes that's because our machines aren't calibrated correctly, and so they're just off, and they're always off. Sometimes the human being who's reading the machine is generating the data, but a person is reading it and then doing data entry, so you can see how that chain of custody could be a problem. So you think, oh, it's really tempting to just have our machine collect and then send the information, but then what happens if your internet is down and your machine doesn't have enough storage to store all of the data that it's collected while the internet was down or the satellite was covered by clouds? Are you going to lose that data? Who knows? So dealing with machines is a problem. Again, setting the database constraints to make sure that the format of your data is correct. Test your machine-generated data. Check it out every day or week or something to make sure that it's what you wanted. And again, with data collection and data entry, handle your training and your overlap appropriately. We are not going to make it through this entire list. I almost never do, but it's super fun. I like trying. I'm a race with myself. Conformance and acquisition. Not null. Not null is also a black hole of data problems. Because if you're going to force me to give you information, I'm going to make things up. And I would bet another donut that every one of you in this room has gotten to use a website and been told, give us your email address or we won't tell you what this article says. And you've said, none your business at nothing doc. Okay, maybe you haven't said that exactly, but you've probably made up what you thought was a fake email address. Yeah. Yeah. And someone is probably going, thank you for signing up for Dodge repair services. You know how I know that? Because I get those emails from someone who probably has my first name, last name. So forcing customers or data entry professionals to give you data that they maybe don't have or that doesn't exist can cause you problems. Because people get creative, incredibly creative. Null, another black hole of data problems. Like I said, Tony Hoare, that's his name. I knew it at one point. So if you force someone to provide a response, or if your radio buttons or checkboxes aren't sufficient to capture what people actually need, we see this a lot now with gender. Male and female simply are no longer enough to discuss the way we even think about the world, and they have never been enough to discuss the way the world actually is. Things that we can do. Talk again to our domain experts. If you have questions about gender, maybe get in touch with a gender expert. If you have questions about nationality or languages, maybe talk to experts in those fields. Practice good knowledge elicitation. Find out how to get information from people so that you can transform that into your database design. Storing and conformance. Again, if you set your database constraints, you can have problems. But also, Postgres really happily will accept any of these values. So if you want to tell Postgres that something is true, you have a lot of interesting ways to tell it that. But it's always going to give you back the same one value for each. And of course, most Boolean operations we think of them as having a null option. So null is just always going to be null. If you have a text field that you're pretending is an integer field, you're going to have a bad day. If you have an integer field that people are trying to enter text into, like I don't know, you're going to have a bad day. So if you have something that should be a Boolean type, please use the Boolean type. I have had clients who have used text fields for Boolean, and it makes me very sad and incredibly frustrated. If you get, if you want an output that is different from what Postgres gives you as the Boolean output, cast it to text and get the output that way, but please don't use it as a text field. You'll make me cry. So the next large concept that we have is consistency. And our question with consistency is largely, is it what we expect? And mostly what we are expecting is that the database is going to change our data in some way. And that way may be not at all, but it may be some other way. And so is the change what we're expecting? If we tell the database to multiply 2 times 2, is it giving us 4 or is it giving us something else? If we tell our database to add this column to the other column, is it getting us the output that we expect? Are there conflicts between data? Is another really big question about consistency. If we've populated a data set into one place, and then we've populated a different data set into another place, it does not matter that those are always the same in both places if it's wrong in one of them. So this is something like, we've got 3 data sets that tell us about buildings. Data set A always says that it doesn't know how tall a building is. Well, that's fine. Database 2 tells us something about the height of the building, but it may or may not be correct. And database 3 also tells us something about the height of the building, but it also may or may not be correct. So now we don't know which of these we trust more. Sometimes they both have the same number, and maybe that number is or isn't right. So sometimes your consistency just doesn't exist, and sometimes, yeah, the database is consistent and that's great, but both numbers are wrong. So consistency is very fun. I really love consistency, but it can lead you to a lot of heartache. Things just don't measure up. As Leia said, you're a little short to be a stormtrooper. So sometimes, if we have lots and lots of data, a little bit of data that's inconsistent or problematic isn't necessarily going to give us a really big problem. One short stormtrooper is fine, but a dozen infiltrating, not actually stormtroopers who mean us ill will, are a bigger problem. And I don't know if you can see the shadow of stormtrooper in the back, but I took this picture in Tokyo, and it's very fun. So if you have data sets, in different data sets in different areas of the database, you can have a big consistency problem. And if your database started with an inconsistency, a logic that changed things in a way you didn't expect, it will continue to propagate that inconsistency, and it will continue to surprise you, sometimes in delightful ways and sometimes in disappointing ways. So coalesce appropriately. If you are in some places going to select one data set, make sure you're always selecting it to represent that as one source of truth. Don't select from different data sets willy-nilly, as they say. Clean your data and document how you cleaned your data so that if somebody, little Bobby Tables, is your data set, you can clean it again in the documented way and get the same data sets, because consistency means this happened in the way that we expected, and a different method will get you a different result. Probably, maybe, who knows? And then finally, setting database constraints to check for consistency is something that I'm a really big fan of. You'll hear me talk a lot about setting the constraints, right? So we're going to look at consistency in storage. Obviously, if we're inappropriately storing our data, we can lose some consistency. Changing granularity is a really easy thing to do in the way that we store our data. It's really tempting to say, I'm going to ask our respondents for their ages, and I'm going to chunk it into 10-year chunks. So I'm going to get 18 to 27-year-olds. I can do math. 28 to 37-year-olds. And then 6 months later, I'm going to realize I need to know who's old enough to drink and who's not. So of my 18 to 27-year-olds, my granularity is bad. So my consistency is a problem. So that's where I'm going to wrap up for today, because we're at 45 minutes. So we have 15 minutes to get ourselves to the next room or grab a glass of water and stay here. I'm going to stand right here and answer questions for as long as there are questions. Does anybody have any questions? Yes.
Have you ever made it through the whole talk?
Have I ever? I actually have. The question was, have I ever made it through the whole talk? And yes, I have. I actually have. The slide numbers are here. I made it to slide 85 in 45 minutes. There are 120 slides in this deck. It's a really fun talk. You had a question?
Yeah, so I've worked with selling data and data analytics in a marketing company over the
Yeah.
last year. Getting into machine learning. What's really interesting about this, it looks to me that a lot of these things are probably things that could have been done starting in the 60s, 70s, 80s, or 90s. Do you have any reason why it's only recently that they started really looking at analyzing data and applying machine learning? Is it because of we have more data now than before, we have more compute processing, or why weren't these things as big of a deal 20 years ago? Why is it only now that things are starting that way?
Okay, that's a great question. So the question, I'm going to sum it up very briefly, was some of the things that I touched on appear to have been relevant through the 50s, 60s, 70s, all the way to now. And is there any reason that people haven't been tackling these problems with something like machine learning? And the answer to that is a couple of things. One, when we use the term machine learning, we're actually possibly referring to 4 to 10 things. So we could be talking about creating a Markov chain or some other type of predictive text type thing. We could be talking about any other kind of algorithm that does a procedure for us. So a lot of these things have been done with different things that we might think of as machine learning. They have been tackled for a long time, yet we continue to struggle with them for the same reason that people keep crashing cars and people keep needing to find different ways to get better insulin delivery. There just are barriers to having perfect solutions. So the question of what is machine learning is a huge one. That's another like PhD. And the question of how much can machine learning do is another one. In general, machine learning can handle extremely specific and very small tasks. It can't really deal with generalized knowledge yet. So we think of a machine driving a car, but that's actually several different algorithms kind of collected together. So in answer to your question, machine learning just isn't that smart yet and may never be. So each of these different categories, machine learning can do something like, what do you think is in this picture? But the machine learning almost always gets a biased data set. Like if you ask machine learning algorithms, is there a giraffe in this picture, or how many giraffes are in this picture? The machine learning algorithms will almost always learn to say yes or give you a number, because they figure out that we only ask those two questions if there's one or more giraffes in the picture. And also rolling hills often get labeled as sheep in image identifying machine learning, because they've learned that the texture of grass is often associated with sheep. There may not be a sheep there. So a lot of these questions really still need to be dealt with by humans because of that bias that gets introduced by the people who are training the thing. And so things like who's going to be a successful job applicant continues to have extremely racist bias, very sexist, also ageist, because it's learned that if someone graduated from college in 1965, we're not going to hire them. So computers are what we train computers to do is not make good decisions, but we train AI and ML to do what a person would have done. So if a person wouldn't have made a good decision, the computer's not going to either. Next question. Didn't the world start in 1970? I don't know, I wasn't here yet. Next question. Yes?
We were talking about front ends collecting data and tying that to database consistency constraints. My experience building web applications and trying to tie them to Postgres is that frameworks that work in handles Postgres errors very badly. And as a consequence, I've been very curious about if there is any discussion of consistency or integrated with handle errors, like data errors.
Yeah, that's very interesting. So the short version of that question is there any discussion of consistent ways to handle errors consistently from the front end handling Postgres errors? Because Postgres usually gives quite detailed error messages or specific detailed messages. If you find error messages, as a side note, that don't make any sense, feel free to report them, because Postgres people work on fixing error messages a lot. I'm unaware of work that's being done to help those transitions, in large part because there are so many front-end frameworks for Postgres to talk to, and also because Postgres and SQL are literally the only things I code in. What I do is so deeply specialized that I really don't... I joke that I stopped having any interest in the front end whatsoever when browsers disabled the blink tag. Again, I'll age myself. Do we have another question?
I was just going to say what we did is we basically made sure that we validated data input on the front end when the user input it. If we had any tools from our data miners, and then when we sent any data to API calls, we were doing validation on both the sending and the receiving side of the call, and then as well before it goes from the data.
So this is where I get into it and wonder who else is going to do things about that.
Yeah.
What if your JavaScript validation does not align with your request validation, doesn't align with your server validation, doesn't align with the constraints?
I am unable to summarize that for the camera, so or for the crowd. There's a suggestion that someone from a company has done some validation on both the front end and the back end, and then the original question asker talked about how complicated that was. I'm going to send you out to discuss that among yourselves, because I just can't get that on the camera or for the rest of the room. I did see another question come up.
What's a typical day for you, like doing data cleaning?
Yes! What's a typical day for me doing data cleaning? Asking a lot of questions. Most of my day is spent saying, did you mean to do this? Why did you do this? How did you do this? Who did this? When was this done? Largely what I'm trying to figure out is not so much myself cleaning the data, but what were the business cases for this data originally? Have those business use cases changed? Were those business use cases really understood by the people who collected or acquired this data in some way? Because usually the people who are using the data in the situations that I encounter didn't actually collect it. They didn't design the the collection. So a lot of the companies that I work with have a lot of different places to get data from, often a credit card processor, often say a reservation system, sometimes a lot of ad tech. So they're looking to see how many people saw our ads, how many people clicked on our ads. And there are some really great talks about how that is a cesspool of data quality problems, because a lot of ad tech people want to show you people saw your ad, because how do they get paid? People click on your ad. YouTube is in a whole lot of trouble right now, theoretically, for boosting their view numbers. Maybe Facebook has done the same thing, but essentially lying to users, producers, and advertisers about how many human beings saw these items. And sometimes it's a bot seeing the item, which is better than nothing, I guess. But bots, not my favorite. So there is no really typical day for me, but mostly I'm writing queries saying, tell me about this, or compare this to this, or I'm trying to recreate an Excel spreadsheet that someone has been populating by hand. So they're going into Looker or into their, their Stripe processor and their reservation system and their complaint system and trying to harness all of these things together. So someone else is spending hours of their day putting together an Excel spreadsheet. So I build some database queries that create a spreadsheet for them, and they no longer have to spend those 3 hours a day, so they can do something else. I'm not the Bobs. I don't come in to get people fired. Any other questions? Next question. Yes?
What sort of techniques do you like to use if you have to maybe interpolate data or infer what data should have been?
I don't infer what data should have been. There are people who do that all day long. I generally don't have enough domain knowledge to be able to make those sorts of guesses. I work with people who are qualified to do that. I can say, a lot of what I say is, did you expect this number? And in the case of the company that literally I went in, and one of the things they needed me to do was connect which specific ad had a purchaser of their product seen. And I was able to connect 9 customers to an ad that they had seen. And their customer acquisition costs have been going down over time. So they knew that people were coming to them through ads, but we just simply could not find which ad. And I asked several people, hey, can you look at these queries that I'm writing? Because I really I'm expecting to find more than 7. And several people looked at my code and said, you're doing this right. Their data is just terrible. So I would never try to say, oh, actually, this should be like 80% of your people saw a specific ad, or otherwise guess, oh, I think maybe this person saw this ad. I just say, I do not know, and I will not guess. I see another hand. Nope, that was not a question? Okay, yeah, you. I thought you raised your hand.
I was going to suggest you misspelled Moore's last name.
Did I? I thought I got it on Wikipedia. Whoops.
You have copied it wrong.
Is there an E in his name? That's incorrect.
That is incorrect.
Oh goodness. Okay, I'll fix that in the online. I use Google Slides. You are consistent in your understanding. Okay. No, I wish I had. So you can all see all of my, and this is how I know that these are shadow stormtroopers, is because I Googled it before my talk. Consistency, accuracy. Tony Hoare. Yeah, there's an E. Yep, that's him. I sure did. All right, so we're gonna, so you can see 118 plus the question slide, plus the here we are for Milan. And you have to sneak an elephant slide into a Postgres talk. I think it's a law. So baby elephants. I'm fixing this now so that I don't forget. Yes, so I think we're going to set up for the next talk. Is the next speaker? Oh, we're done. I was number 3 this afternoon. Thank you so much for your time this afternoon. If you have any questions, feel free to approach me for the rest of the conference. I'll either be attending talks or I will be sitting at the Postgres table. Also, if you're interested in volunteering to sit at the Postgres table and meet people, you are certainly welcome to do that. We love having company at the table, and we love having a broad variety of representatives. So there are a lot of people here at Scale who have never met anyone from the Postgres community. So having people who look like all of us is really, really awesome. So yeah, we'll be in the exhibition hall starting tomorrow, I think at 2 o'clock. And we'll have more talks in these rooms tomorrow as well. Thank you all so much.